Okay, we're just going to look at solving some problems with the tide tables. First, a very basic look at the tide table. Calculate predicted times and heights of high water and low water and ranges for Liverpool on the 5th of October. Okay, Liverpool is a standard port, so we simply go to the tide tables for Liverpool, October. We'll go down to the 5th of October and we write down for the 5th of October the values, which I've done here. 0403 hours 1.2 metres, 0942 9 metres, 1621 2156. So we've written down the values there, and that's it. They are the times and heights of high water. Now the ranges, well, a range is between low water and high water, low water, low water, high water. So the values, the difference is there. That's 7.8, 1.2 to 9 is 7.8, 1.4 to 9 is 7.6, and 1.4 to 9.5 is 8.1. So they are the ranges between high water and low water. So that's just a very simple problem looking at the tide tables. So let's look at one a little more involved now. And what we're looking at here in this problem, we've been asked to find the height of tide at Ullapool at 0431 on the 1st of January. Ullapool, again, is a standard port. So we go to Ullapool on the 1st of January and we're asked to find a time 0431. So we go to the 1st of January and we need to write down the two times either side of 0431 and of course the two heights either side of 0431. 1st of January, low water 0132, 0.8, high water 0731, 5.3. So we've written those values down from the information given on the tide table. That information there, that page, we've finished with now. We've got the information that we need. So we've written them down here, and I've put an arrow here indicating that our time is 0431 that we want. So it's obvious that our height of tide is going to be between 0.8 and 5.3 because the time is between 0132 and 0731. High water and low water, we've written the values down there. You must always do that to get a range. So the range between the two is 4.5 metres. And if we look at the graph for Ullapool, the mean range is written here. Springs is 4.5, Neeps 1.8. Also, you'll see one is indicated as a straight line, one as a dotted line. When you look at the graph, you have a straight line and a dotted line. That's what that indicates there. So on the graph, mean range is Spring 4.5, Neeps 1.8. We can see that our range is 4.5. So when we go to these ranges, we can see, well, it's the spring range of 4.5. So that's the range that we would use. Now, if the range that we'd calculated between these two had been more than 4.5 metres, then we would have used the spring range. Had by calculation the difference between these two been less than 1.8 metres, which is the neat range, we would have used the neat range. So any values you get less than the neat range, you use the neat range. Any values you get for mean ranges more than the spring range, use the spring range. So we know it's 4.5. Our high water time we have here is 0731. Okay, 0731 is the high water time. So we can write in at the bottom of this graph here, high water 0731. Okay, the time we want is 0431. So high water is 0731, minus 1 hour is 0631, minus 2 hours 0531, minus 3 hours 0431. So we can write the times in there, and we know that on this 3 hour mark that is 0431. Incidentally, between the hours 2 and 3, 3 and 4, etc., there are 6 marks. So each gap is 10 minutes. So if our time hadn't exactly been the 3-hour difference, we could have gone between these times. So what we do now, we know it's 3 hours before high water. So on the graph, at 3 hours, we go straight up there. And we go up till it hits the spring mark, because our range was 4.5, spring range is 4.5. So where it hits the spring mark, we go across like so. And we go across to this line here. Now I'll just explain this line here. When we've got our low water and high water values, and we got those from the tables initially, we go to our graph, and at the bottom it says low water, at the top it says high water. So the low water value of 0.8 we go to there, the high water value of 5.3, which is there, we go to there. And what we do then, we simply draw a line from the 0.8 up to the 5.3. So what that's saying is that's the low water value and that's the high water value. And our value is going to fall somewhere between those two. So at 0431 we've gone up to the spring graph, the complete line, gone across to where it has hit the line between low water and high water. Then we go up to the top to get our value. We could actually go down to the bottom as well as the top, because the values are the same at the top and bottom. And we can see that the height is 3.2 meters. So what we're saying is that at 0431 GMT, the height of tide was 3.2 meters, which is between 0.8 and 5.3. So we've got our height of tide at 3.2 meters. Now, if you think you needed to do the opposite, if in this example we were asked to find the height of tide at 0431, what if we'd been told to find the time of the tide at a height of 3.2? Well, all we would have done, we'd have drawn our line there, we'd have found 3.2, gone down to where it hit the line and gone straight across, and then we'd have gone across to the curve, which was either before or after high water, and the value you were looking for, it would be obvious whether it was before or after high water. Then you would simply come down to the times and read off your time. So you just simply do the opposite. So that's a very straightforward problem where you're using a standard port and you're needing to find either the height of the tide or the time. And in this simple problem, our range of 4.5 between high water and low water was the same as the spring range. So we simply used the spring graph. We'll have a look at a problem where it isn't that straightforward and where our range falls between the springs and neaps. We'll have a look at one of those later on, but that's a fairly straightforward problem with a standard port value.